Okay. Good evening. Good evening, friends. Okay. First, I would like to extend my sincere thanks to all the participants for attending this workshop. Okay. Today, we are going to discuss statistical tool application in research. Okay. Before discussing statistical tool application in research, just I would like to recapitulate what we discussed so far for 2 to 3 minutes, so that then you can recollect what we discussed so far. We have seen what is research problem. We have seen. Next, we have seen what are the various sources of identifying the research problem. We have seen how to formulate the research problem. Next, we have focused our attention to review of literature, sources of review of literature. What are the different strategies followed by the researchers while writing a review of literature? We have seen different approaches. Then we followed research design. We have discussed 2 types of research design. One is a conclusive, another one is a non-conclusive research design. Under conclusive research design, we have seen exploratory research. Under non-conclusive research design, we have seen descriptive research and casual research. Again, we have seen what is cross-sectional, what is longitudinal research design. We have seen under what circumstances we are supposed to use exploratory research. We have seen under what circumstances we should use descriptive research and casual research. Then we discussed about questionnaire. What is questionnaire? What is construct? Next, we have seen what is variable, what is item, what is formative, what is reflective, how questionnaire should be. Next, we have seen another one important component, that is sampling method. We have seen what is sampling, what is target population, sampling framework. Next, sampling, we have seen what is random sampling, what is non-random sampling. We have seen what are the different methods used in case of random sampling. We have seen what is non-random sampling. We have seen what are the major difference between random sampling and non-random sampling, under what circumstances or condition in which random sampling can be used. How do we calculate sample size formula when population is unknown? We have discussed. Again, yesterday we have seen what is primary data and we have seen what is secondary data. What are the different methods available for collecting primary data? We have seen qualitative data and quantitative data. Quantitative data can be collected by survey method, and another one is observation method. Next, we have seen the qualitative data. Qualitative data can be collected by different methods. Say, for example, there is direct, that is non-disguised, indirect, disguised. We have seen focus group. We have seen depth interview. We have seen projection technique. We have seen construction technique. We have seen other technique like case study method, and we have discussed ethnography method. Okay. Now we are going to discuss another one important aspect in the research methodology. This is dear participants, tell me whether my voice is clear now.
Yes, sir, very clear.
Okay, sir. Okay. Today we are going to discuss another one important and interesting information, that is data analysis. How to analyze the data. Okay. Before proceeding further, just I would like to discuss some nuances of data analysis. Normally, let's take data analysis. Data analysis is not an independent activity. Data analysis is a dependent activity. How data should be analyzed? Data should be analyzed or statistical tool. You can use any statistical tool. Before using statistical tool, first you should have an objective. Okay. You can have 3 objective, or you can have 4 objective, 5 objective, 6 objective. If you have 6 objective, you should have used 6 statistical tool. That is very, very important. Either it could be parametric or either it could be non-parametric statistical tool. What is parametric? What is non-parametric? If any statistical tool is considering mean as a base, if any statistical tool is considering mean as a base, means it is a parametric to a test. if any statistical test is considering median as a base, it will comes under non-parametric test. Okay, so we have identified objectives. Based on the objective only, questionnaire should be prepared. So there is a relationship between objectives of the study and questionnaire. Okay, normally let's take, you might aware about the questionnaire. Normally questionnaire consists of, this is a normal, I'm talking about normal questionnaire. Let's take primary data. Normally questionnaire consists of three important components. One is a demographic profile of the respondent. Second part is a independent variable. Third part is a dependent variable. Demographic profile, first part. Second part, independent variable. Third part, dependent variable. Okay. Whenever we do analysis, particularly statistical analysis, either parametric or non-parametric test, first we should identify what is independent variable, what is dependent variable. This is very, very important. In case of statistical test, we need to identify independent and dependent variable. Okay, then only we can proceed further. So what is independent variable? What is independent variable? Independent variable are a cost oriented variable. Independent variable are a cost oriented variable. What is dependent variable? Dependent variable are a effect oriented variable. Independent variable are a cost oriented variable. Dependent variable are effect oriented variable. Okay, let's take a questionnaire. Let's take questionnaire. Second part of the questionnaire talks about independent variable. Third part of the questionnaire talks or deals about dependent variable. Okay, now you may ask another one questions. Okay, sir, you said some questionnaire should be developed based on the objectives of the study. Now we should know which scale we are supposed to use in the questionnaire. There is a relationship between statistical tool application and usage of scaling technique. Normally, you may aware about this concept. We have been using 4 different types of scaling. The one is nominal, another one is ordinal, another one is interval, another one is ratio scale. When you combine nominal and ordinal, the other name of nominal and ordinal is said to be categorical variable. When you combine interval and ratio scale, it is said to be metric variable. Either you should have nominal, categorical or metric variable. Say for example, you have formulated a questionnaire. Your questionnaire has more number of nominal and ordinal data. In such circumstances, you cannot use parametric test. Normally, let's take nominal and ordinal data. Nominal means what? Gender of the respondent will come under the category of nominal. Say for example, let's take ordinal, age of the respondent, income of the respondent, educational qualification of the respondent will come under ordinal data. Okay, so what is the thumb rule? You can have nominal and ordinal data in demographic profile. Nominal and ordinal data, you can use nominal data and ordinal data in a demographic profile of the respondent. Okay, what about interval data? What about independent variables? You can use nominal, ordinal, interval scale or ratio scale in the independent or dependent variable. If you have followed this pattern, then you can use any statistical test. Normally, statistical test can be used based on the objectives. Even, for example, for the sake of using statistical test, for example, you like to use some statistical test. Okay, even though it is not there, just the sake of using stats, you'd like to use some statistical test. This is possible. So, what is the strategy we are supposed to follow in case of statistical tool? First, we should formulate the objective. If we have 10 objective, we should use 10 statistical tool. That is the first one. Another one important thing, all the questionnaire should be formulated based on objectives of the study. Okay, how questionnaire? There is a relationship between statistical tool application and questionnaire. For example, you'd like to use t-test In such circumstances, what is the thumb rule? One variable should have two variable, one independent and one dependent variable. One variable should be measured at 5-point scale. Another one variable should be measured at in the nominal scale. Okay. So from this, what we can infer? You can use nominal and ordinal scale in the first part of the questionnaire. That is the demographic profile of the respondent. You can use independent variable. You can use 5-point scale at independent and dependent variable. Okay. With this is a basic aspect of the statistical tool development. Now, just I would like to share my PPT. Kindly whether you can see the PowerPoint presentation. Any one of the respondents, any one of the participants kindly acknowledge. We can also acknowledge through chat box. Whether you can see the PowerPoint presentation. Okay. Then say for example, what is the normally let's take researchers. They will write some introduction. They will write some objectives. Review of literature. They will have some objective. They will write some research methodology. They will develop some questionnaire. They will go to the field and they will collect some data. They will come and they will do the analysis. Okay, that is not a proper. There should be a systematic process. What is the role of researcher? The role of researcher means the role of researcher here. What is the role of researcher? The role of researcher is analysis. The role of analysis is boil the data, filter the data, and distill the data so that the society might receive good data. We have collected data from the respondent. All data are not good data. For information, all data is not good data. Data has some error. So what we should do before doing statistical analysis, we should remove the error. Okay. So we are going to discuss what are the different processes are to be followed before data analysis. Okay. We have seen normally let's take a research. Research can be classified into two types. One is a qualitative research, another one is a quantitative research. In case of quantitative research, normally variables are defined in two different categories. One is independent variable, another one is dependent variable. Okay. Already we have seen what is independent variable. Independent variable are a variable this is a cost-oriented variable. What is a dependent variable? Dependent variable is the effect-oriented variable. So we have seen how the scale should be used in a questionnaire: nominal, ordinal, interval, and ratio scale. Okay. Next, we have also seen what are the process involved in the questionnaire development. Okay. Now you have collected data. You have okay. Sir, whether PowerPoint presentation is visible?
Sir, it is not visible, sir.
Yes, madam. Just now, I will. Now it's visible, ma'am.
Yes, sir.
Okay, madam. Okay. So before doing statistical analysis, first we should clean the data. What is data cleaning? Data cleaning? Data cleaning is a process of detecting and correcting or removing corrupt or inaccurate record from the set of table or database and refers to identifying incomplete, incorrect, and inaccurate, irrelevant parts of the data, and then replacing, modifying, or detecting the dirty data. I will explain what is data cleaning. Whenever we collect data, we should not use statistical test immediately. We should clean the data because the data has some error. Say, for example, some data are incomplete data, some data are incorrect data, some data are inaccurate data. So now I'm going to explain how data can be cleaned. Okay, what is how data can be cleaned? For example, if you have not cleaning the data, just you have used the data for data analysis, it's like, the doctor treats you without understanding your problem. Okay, so as a result, what will happen if we do the data analysis as it is? What will happen? It will make a significant hypothesis as an insignificant hypothesis. It will make significant hypothesis as an insignificant hypothesis, or sometimes it will make insignificant hypothesis as a significant hypothesis. Okay, so how data can be cleaned? Okay, data can be cleaned by different methods. Okay, first one is we should identify the missing value in the data. Missing value in the data. Normally, you might enter data in the SPSS. Okay, it is so SPSS is said to be another software. It is another software. Okay, so you have entered your data. Okay, sometimes when you ask some sensitive question, the respondent may not answer the questions, or otherwise sometimes when you give, if you have not selected proper respondent, proper sampling unit, probably they may not fill the questionnaire. They may not fill the questionnaire. So you will have a missing data. You will have a missing data. Okay, if you have one or two missing data, it's okay. One or two missing data, it is okay. That is acceptable. Whereas, let's take, you have huge missing data. That is not acceptable. For example, in such circumstances, what we should do? We should replace the missing data. Okay, how missing data can be replaced? Missing data can be replaced by different method. You can calculate mean of the particular variable. You can replace it. This is one way. Or otherwise, you can also interpolate, or otherwise you can also extrapolate. This is also possible. But let's take, you have one column, gender of the respondent. Okay, so what are the two possible way? Either you can write male or female. If it is a male, probably they can enter 1. If it is a female, then probably the respondent should enter 2. There is a blank. Okay, normally let's take, when you ask questionnaire at 5-point scale, what you can do is you can calculate average for all the variable, and you can place this average as in the missing value. That is acceptable. Whereas let's take gender of the respondent. 1 means male, 2 means female. Now 1 plus 2, 3. 3 divided by 2, 1.5. So that means logically it is not good. So judiciously we should do this exercise. Okay. So then the data should not the data should not have any missing value. This is very, very important. Okay, if the data has more missing value, what we can do is we can collect extra data, or otherwise what we can do is, whenever we do statistical analysis, there is an option in every statistical tool: exclude missing value. When you exclude missing value, then when you do the statistical analysis, your software, that is SPSS, will exclude the missing value data. For example, you have 200 observations. You have 200 observations. Okay. Now let's take, out of 200 observations, 30 are incomplete. That means 30 are incomplete. Okay. Now what you are supposed to do? You calculate mean, or otherwise you can collect extra data. You can remove this data. Now just imagine that you are at the verge of completing your research program. Already you have decided to submit your synopsis and thesis. Now what you can do? It's very simple. What you can do is simply you can use this option, exclude missing value option. When we do the statistical analysis, I will explain this aspect. Okay. So first one, missing value. Okay. First we have to check the missing value. Okay. Next we have to check another one important aspect, that is outlier. Next one is outlier. So what is outlier? What is meant by the term outlier? Outliers are outlier. What is outlier? Outliers are observation with a unique combination of characters identifiable as distinctly from other observations. For example, let's take here, I think several X are there. One X seems something different. This is an example for outlier. So what is outlier? Outliers are the observation with unique combination of characteristics identifiable as distinctly different from other observation. For example, and then I will give one example for outlier. Let's take, you have prepared some questionnaire. Gender of the respondent. What are the two options? What are the two options? Either you can assign 1 or either you can assign 2. Somebody assigned 3 in the place of 2. The 3 is said to be outlier. Similarly, you have asked 5-point scale. You have asked one questionnaire at 5-point scale. So what are the maximum possible way? What are the maximum possible way? You can ask, you can, and then probably the respondent can give answer at 5 point. Either they can give 1, or they can assign 2, or they can assign 3, they can assign 4, or they can assign 5. But whereas you have received one respondent has assigned 10. The 10 is said to be outlier. So we should be very cautious with regard to identification of the outlier. But whenever we remove the outlier, we should be very cautious. For example, we have asked one question: what is the age of the students? What is the age of the MBA students? Normally, let's take what is the age of the MBA students. For example, up to 17 years, they might have completed 12th standard. Then let's take 4 years. Within 4 years, they might complete BE or BTech. Or if it is arts, probably they will take 3 years, 20 or 20 plus 21. Okay. So probably 21 or 22, maybe maximum age of the first year MBA students. Okay. One student has entered 28 as a age. 28 as a age. Immediately, we should not come to the conclusion that he is an outlier. He or she is outlier. Why? Because he may have a arrear. Just now he might join the MBA program. So we should be very cautious before taking before come to the conclusion that the particular value is a outlier. Okay. Now we should remove the outlier. If you have not removed the outlier, what will happen in case of statistical analysis? It will increase the value of mean. It will increase the average value. As a result, what will happen? It will make significant hypothesis as a insignificant hypothesis. Insignificant hypothesis as a significant hypothesis. Normally, let's take, you have 2 types of hypothesis. Normally, we formulate 2 types of hypothesis. One is null hypothesis. Another one is alternate hypothesis. We have formulated 2 types of hypothesis. One is null hypothesis. Another one is alternate hypothesis. What is our intention? What's our intention? We should remove the, then say, for example, what is our, then say, for example, what's our intention? We should reject null hypothesis. That is our intention of formulating hypothesis. Okay. But if you have not removed outlier properly, what will happen is you might reject alternate hypothesis, even though it is true. So this kind of problem will come in case of if you have not removed outlier. I can give an example for outlier. Why outlier? Why do outlier occur? What is the reason for outlier occur? For example, first data entry error. You have collected data from the respondent. Okay, you are going to enter the data. Okay, before entering data, normally let's take, you will assign some value for the data. If the question has been asked at 5-point scale, then these are the possibility. Either you can enter 1, 2, 3, 4, or 5. While entering data, wrongly you have entered 15. instead of 5, you have entered 50. This is said to be the data entry error. This is said to be data entry error. As a result of this data entry error, what will happen? The mean value of the particular column will be increased. So this is not a real mean, or this is not real average. So it will affect the further data analysis. Second one, extraordinary event. Sometimes, say for example, you would like to measure the rainfall of the particular district. The particular district may be situated on the nearby the coastal area. Probably the particular district might experience cyclone. During the particular month, the district might experiencing huge rainfall because of the cyclone or because of the hurricane. In such circumstances, if you calculate what is the average rainfall without removing this, your average could be something very high, but this is not true. So we should remove this kind of outlier. Next one, extraordinary observations. What is extraordinary observation? Sometimes, say for example, you will have some extraordinary observations. Extraordinary observation means, I can give an example for extraordinary observations. You have given a questionnaire to the respondent. Some of the respondents might assign the value without going through the questionnaire. These people are termed as a unengaged respondent. Normally, these people are termed as a unengaged respondents. I can give an example. One biscuit manufacturing company wanted to know the average consumption of the biscuit. So they have issued a questionnaire to their customers. Okay, one customer has filled 5 biscuit, 10, 15, 20. Another one customers set 25, another one customer set 35, 40. Okay. So what is the intention of the biscuit manufacturing company? The biscuit manufacturing company is supposed to calculate average or mean, based on which they are supposed to produce the biscuit. For example, if the average biscuit consumption is 25, probably the biscuit manufacturing company is supposed to accommodate 25 biscuits in a single packet. This is their intention. But one person, without reading the questionnaire, he put 10,000. He put only 10,000. As a result, what has happened? The average biscuit consumption has increased very significantly. Now he has calculated a mean. What is the average? 2,000. That means from this, what we can infer? Every family in India, on an average, they have consumed 2,000 biscuit. Just imagine if they have produced biscuit with 2,000, if they can accommodate 2,000 biscuit in a single packet, what will happen? That's not correct. Okay, so first we should identify the missing value. Next, we should remove the outlier. Outlier means it's an observation with unique combination of characters, identifiable as distinctly different from other observation. Okay, this is an example. This is the example for outlier. Outlier. Okay. Why do outlier occur? Say for example, it may be because of the data entry error. Say for example, sometimes extraordinary event. Okay. Next one. This is another one. This is another one reasons. We are supposed to clean our data. Some respondents are considered as the unengaged respondent. What is unengaged respondent? They are not a real respondent. They are not a real sampling unit. Okay. But once you distribute the questionnaire, they will not return the questionnaire. What they will do is, even though they don't know anything about the questionnaire, or even though they may not be the customer, what they will do is simply they will enter 1, 2, 3, 4, 5 for all the questions. They will assign 1, 2, 3, 4, 5 for all the questions. Or otherwise, simply they will assign 1, 1, 1 for all the questions. Or otherwise, simply they will assign 2, 2, 2 for all the questions. Or otherwise, they will assign 3, 3 for all the questions. Okay. Now, how to avoid this kind of, this unengaged respondent? this kind of unengaged respondent can be avoided by only one way. You can ask the reverse coded questions. You can ask the reverse coded questions. What is reverse coded question? Normally, let's take, if it is excellent, you can assign 5. Very good, you can assign 4. Good, you can assign 3. Okay, you can assign 2. Not okay, you can assign 1. This is the normal pattern. This is the normal pattern followed by the researchers, followed by the researcher. Okay. You would like to know whether the respondent is a engaged respondent or unengaged respondent. What you can do is, in between, you need not ask all the question. In between 1 or 2 questions, you can ask this. You can change the word. If the product, if for example, if it is very excellent, you can ask the respondent to assign 1 mark. If it is very poor, you can ask the respondent to assign. You can ask the respondent to assign only very poor 5, excellent 1. Now you can identify whether the respondent have responded to your question properly. When you enter the data, if they set very poor, accordingly we can make changes. So this is the way of identifying unengaged respondents. Okay. So just I would like to recapitulate what we discussed so far. We have seen data analysis. Data analysis is not an independent activity. Data analysis is a dependent activity. Before proceeding with the data analysis, data should be, say for example, questionnaire should be formulated based on the objectives of the study. In the normally, let's take questionnaire. Questionnaire consists of 3 important components. First part of the questionnaire talks about independent variable. Second part of the questionnaire talks about dependent variable. Third part of the questionnaire, first one in demographic profile. Second one independent variable. Third one is dependent variable. Whenever we use a statistical tool, we are supposed to identify independent and dependent variable. You can use 4 types of scale in construction of in development of the questionnaire. Either you can use nominal, or either you can use ordinal, either you can use interval, or either you can use a ratio scale. If you have used nominal and ordinal scale in your questionnaire, you can use only the non-parametric test. That means you can use only the non-parametric test. If you have used nominal, ordinal in demographic profile, 5-point scale at independent variable, 5-point scale at dependent variable, you can use parametric test. Okay. Now we have seen what is data cleaning. We have seen first we are supposed to remove the missing value. First, that's the first one we have seen. Next, we are supposed to remove the outlier. We have seen. Next, we have seen what is unengaged respondents. We have seen what are the reason for outlier. Okay. Now let's take statistical analysis. Normally, we have used 2 types of statistical test. One is parametric, another one is non-parametric test. Okay, what is parametric test? This test assume that variable of interest are measured at least on interval scale. That means, in other words, if any statistical test is considering mean as a base, is known as parametric test. If any statistical test is considering median as a base, means it will be termed as non-parametric. It will be termed as non-parametric test. That means if you have used a nominal and ordinal scale in your questionnaire, you can use only non-parametric test. Okay. I think this slide may not be visible. Okay. Say for example, I will show another one, a word file. This word file will clearly indicate, okay, for example, which statistical test you are supposed to use. Okay, then I can tell orally. Okay, for example, again I will show the PowerPoint. I have prepared the same thing in word file. Just I will show the word file. Okay. I think this is not that Word file. Then I will show that Word file before wind up the session. Okay. Let's take a statistical tool. You have two sampling unit. Okay. You would like to know the significant difference exists among these two group of people. Significant difference. What is significant difference in case of statistics? We may use the word significant. What does that mean by the term significant? I can give one example for the term significant. One student have secured 100 marks in first cycle test. One student have secured 100 marks in first cycle test. In the second cycle test, the same student have secured only 2 marks. See, what is the difference? 98. That means this is a significant. Whereas one student has secured 1 mark in the first cycle test. The same student have secured 1 mark in the second cycle test. The same student have secured 2 mark in the first cycle test. Tell me whether this is significant. No, this is not a significant. Okay. For example, let's take this is your study. Bank selection criteria adopted by MBA students. You would like to check why male student have selected MBA program, bank selection criteria, or which attribute is motivating male MBA students to select the bank. Similarly, you would like to check why female students have selected the bank, whether male perception are the same towards the female. You can ask the questions. Okay, if in such circumstances, if you want to compare two group of population, one may be male or another one may be female. Now, what you can do is you can use one independent sample t-test. For doing independent sample t-test, one variable you should ask one variable at 5-point scale, another one variable at nominal scale. This is the logic of independent sample t-test. Similarly, you would like to measure the significant difference exists among three group of population. For example, small scale industry, medium scale industry, and large scale industry. Their perception towards government attitude towards the entrepreneurship development. Now, what you can do, it is with more than two. You can use one-way ANOVA. Similarly, you would like to measure the relationship between independent variable and dependent variable. Just you would like to measure the relationship between independent variable and dependent variable. So now what you can do, you are supposed to use only correlation. You are supposed to use only correlation. Correlation has been used to check the relationship between two variables. Sometimes you can measure relationship within independent variable. Sometimes you can measure the relationship between independent variable and dependent variable. You can measure correlation. Okay, this is also possible. Now, for example, you would like to measure the impact of independent variable on dependent variable. You would like to measure the impact of independent variable on dependent variable. Now, what you can do is you can use simple correlation or multiple correlation. What is simple correlation? What is multiple correlation? What is simple correlation? In case of simple correlation, you can have only one independent variable. You can have only one dependent variable. When you have only one independent variable, you like to measure the impact of independent variable on dependent variable. You can use simple regression. Similarly, you have several independent variable. You have 5 or 6 independent variable. You have only one dependent variable. In such circumstances, you can use multiple regression. In such circumstances, you can use multiple regression. Okay. Now, just I will okay. I will just I would like to discuss some statistical analysis. Okay. Dear participants, whether you can able to see the SPSS file. Any one of the participants can tell me, okay, you can see the SPSS file. Okay. I would like to share a questionnaire for the SPSS file. Okay. Okay. Probably now you can see the questionnaire. Normally the questionnaire has been prepared in Word file. Questionnaire has been prepared in Word file. Now just I have said questionnaire. Okay. See, what are the objectives of the study? This study is approached with the following objectives. What is the study? This is one of our students' project. The title of the project is this is the title of the project. Employee expectation from employer in a textile industry. Employee expectation, what employees are expecting from the employer in a textile industry. Okay. So the researcher approached the study with 3 objectives. What is the first objective? To identify the important dimensions of employee expectation. This is the first objective. What is the second objective? To study the relationship between employee expectation dimensions on job satisfaction. I think there is a spelling mistake in second objective, to study the relationship between employee expectation dimensions on job satisfaction. What is the third objective? To examine the influence of identified dimensions. To examine the influence of identified dimensions on job satisfaction. Okay. Now let's take for first objective to identify important dimensions of employee expectation. Probably you can use factor analysis. Okay. What is factor analysis? For example, already we have seen this concept in research design. We have seen the exploratory research. What is exploratory research? You are doing research for the first time. There is no research, there is no previous research so far. So what you are doing? Just you are doing research for the first time. In such circumstances, what you can do is you are exploring. In such circumstances, you can use exploratory factor analysis. For example, if your study is an exploratory study, you can use exploratory factor analysis. Or otherwise, the other name of exploratory factor analysis is said to be factor analysis. Or otherwise, the other name of exploratory study is said to be data reduction technique. Data reduction technique. Okay. Whereas if you know your construct well in advance, you need not use the factor analysis. You can use confirmatory factor analysis. Okay. First objective, you can use factor analysis. But the second objective, to study the relationship between employee expectation dimensions on job satisfaction. You can use correlation. Third objective, to examine the influence of identified dimensions on job satisfaction. You can use multiple regression. See, this is a questionnaire on employee expectation from employers: name, optional, age, gender, nominal scale, age, ordinal, designation, nominal scale, years of experience, nominal scale, monthly salary, ordinal scale, nature of the family, nominal scale. Okay. They have asked some questions. Does management treat employees equally within the organization? And then questions has been asked at 5-point scale: highly agreed, neither agreed or not, disagreed, highly disagreed. That means question has been asked at 5-point scale. The researcher has developed 25 questions. These are the questions. Almost all the questions has been asked at 5-point scale. Okay. Probably there is no, if you take this questionnaire, there is no dependent variable. Almost all variables are independent variable. Okay. So based on this questionnaire, the researcher has collected the data. The researcher has collected this data. This data has been entered in SPSS. Okay. Now let's take how many data has been collected? 172 data. 172 data has been collected by the researchers. Okay, if we take SPSS file, you might have seen 172 number of cases. Normally it is termed as cases. So the researcher has collected 172 cases. Okay. Say for example, let's take, we have seen missing value. How to calculate, how to identify the missing value. For example, purposefully I am dedicating to value in case of gender. Okay, I have deleted 3 value in case of gender. Now, what I can do is, I'm going to first I'm going to calculate descriptive statistics. Descriptive statistics. Okay, what is the descriptive statistics? Normally, descriptive statistics might be calculated to describe the demographic profile of the respondent. Okay, with the help of descriptive statistics, for example, you can calculate mean, median, mode, percentile, standard deviation, coefficient of variation. We can also calculate what is the minimum value, what is the maximum value. Everything is possible. Even let's take, you can also calculate spinous, kurtosis. Everything is possible in case of with the help of descriptive statistics. Okay. Now my intention is to create a descriptive statistics, or otherwise frequency table. Frequency table. Okay. So let's take all the data. If you want to do some analysis, statistical analysis, then before then all the data, you can analyze all the data in, and this you can analyze all the data here. That is, you can go to analyze. You can go to analyze. You can go to analyze. Okay. Before that, SPSS has two different view. One is a data view. We are in the data view. Another one is a variable view. This is a variable view. Say for example, let's take variable view. In case of variable view, for example, let's take, we can see the variable. We can see the variable. Okay. Now we can go with the data view. Okay. Now just I'm doing the frequency table. How I can do the frequency table? I can go to analyze. I can go to descriptive statistics. I can go to descriptive statistics. Then I can select frequencies. I can select frequencies. Okay. Now what I can do is, just I would like to prepare frequency table. I would like to prepare frequency table for gender of the respondent. Gender of the respondent. Okay. Then just I have prepared frequency table for the gender of the respondent. Okay. Now let's take the first one, statistics. First one, statistics, gen, valid. Valid means 172 cases has been collected. That means 172 respondents gave answer. 172 respondents answer has been entered in SPSS. Out of 172, what is the missing value? Let's see the statistics. What is the missing value? 4 data are missing. 4 data are missing. Okay. If it is 4, it's not a problem. You can proceed further. It's not a problem. You can calculate mean. But if it is a demographic profile of the respondent, we cannot calculate mean, and we cannot calculate mean. Why? Because let's take demographic profile of the respondent. Let's take gender. We may assign 1 for male. We may assign 2 for female. When we add 1 plus 2, it's a 3. 3 divided by 2, what is the average? 1.5. Say, for example, can you say any variable with 1.5? That is not correct. Meaning wise, this is not correct. Okay. So this is the way of identifying the missing value. Now I can see. Let's take. I can also similarly I can also prepare a frequency table. How frequency table can be identified? I can go to analyze, descriptive. I can select descriptive. I can go to analyze. I can go to descriptive statistics. Then frequencies. I can transfer this variable age. simply I can transfer this variable destination. I can transfer this variable work experience, nature of the family, a monthly salary. Okay. Now what I can do, I can calculate a frequency table. See the age of the respondent, designation, work experience in organization, nature of the family, monthly salary, everything can be prepared with the help of descriptive statistics. Similarly, what you can do is you can also calculate cross tabulation in descriptive statistics. Cross tabulation, for example, you can assign some value in rows. You can assign some values in columns. Okay. You can also prepare frequency table. See, cross tabulation. This is an example. This is an example for cross table. Okay, gender plus. See here, gender plus cross gender. You can also prepare cross tabulation. Okay, gender plus age of the respondent. So you can prepare cross tabulation. Okay. Now, say for example, we have seen how to identify the missing value. Okay. How missing value can be identified? Missing value can be identified with the help of frequency table. Okay. Now we have seen another one outlier, another one concept called outlier. How outlier can be identified? This is the way by which outlier can be identified. Okay. Go to, you can prepare the descriptive statistics. You can prepare the descriptive statistics. Okay. You can descriptive statistics. Let's go to analyze descriptive statistics, frequencies. Okay. Then just what is our intention? Our intention is to check the data, whether the data is good or is there any outlier. What you can do is simply you can go to this option, statistics. You can go to this option, statistics. Okay. Kindly enable this options. When you go to statistics, you can when you go to statistics, say for example, you can get this data. Say for example, you can get this data dispersion. Okay. You can enable this option, minimum and maximum, continue. Then you can click OK. Okay. Now let's take here. Here. Okay. There will be one table. There will be one separate table. From this table, what you can infer? What is the minimum value? Minimum is 1. What is the maximum value? Let's take a gender. Minimum 1. Maximum 2. There is no outlier. So if it is a male, normally we may assign 1. If it is a female, we may assign 2. Let's take age. We have 5 different classification. Let's take here. We have classified the respondent in different category. For example, let's take age of the respondent. Age of the respondent. Let's take a variable view. Age of the, let's take age of the age, name, gender, age. Okay. See? Yes, sir. Okay. Okay. Let's take here. Five. There are 5 classifications. 1, 18 plus 25 years. 2, 26 to 35 years. 3, 36 to 40 years. 4, 41 to 45 years. 5, above 45 years. So 5 classifications are there. 5 classifications. That means we have let's take a age of the respondent. We have classified the age into 5. That means the minimum value should be 1. The maximum value should be 5. Then only there will be no outlier. Okay. Let's take the analysis. You can prepare the descriptive statistics. Let's take the age of the respondent. Just going to just click statistics. Just enable this option, minimum and maximum. You can click this option, continue.
Sorry to button, sir.
Okay.
SPSS screen is there, sir. Actually, the word file is given. You go to screen share and share the SPSS.
Yes, sir. Sir, I have set both screen share and SPSS.
No, sir, SPSS.
I think probably, yes, I understand. Probably the output may not be visible. Am I right, sir?
Yes, sir. So, look
Yes,
to
yes.
that one, then it will be visible.
Yes, sir. Then just I will, sir. If it is a
So, stop it directly.
Yes.
Click the
okay, say for example, just I will share the output. Okay. Now it's visible, sir. Output.
no, sir. Still word file.
Okay, sir. Let's take age of the respondent. We can classify the age into 5 different category. Okay. Now let's take the statistics part. Now let's take the statistics part. Minimum. What is the age? Minimum 1. What is the maximum? 5. Minimum 1, maximum 5. So there is no outlier. This is a way of calculating outlier. So there are several statistical techniques are there. What is simple? Simple means what? Once you know the concept, you can calculate outlier. Okay. Now, before discussing further, whenever we do the analysis, first you should do 2 different analysis separately. Okay. You are aware about this analysis, reliability of the data. What is meant by the term reliability? We will check what is meant by the term reliability of the data. Every statistical tool has some basic assumptions. We should follow the assumptions. Normally, we may get some thesis for evaluation. Sometimes we will send our scholar thesis to some foreign countries for evaluation. First, they will ask the questions whether the researcher has checked the assumptions of the statistical tool. For example, every statistical tool has some assumptions. What are the normal assumptions of the statistical tool? Any statistical tool, normal assumptions. If you take almost all the statistical tool, almost this assumption is a common. What is the first 2 assumption? Say, for example, there should not be any missing value. This is the first assumption. This is the first assumptions of any statistical tool. Next one, there should not be any outlier. This is the second assumptions. Next one, then all the values should have an independence of observation. All the values should be measured at independence of observations. What is independence of observation? That means you should collect data from the respondents only once. That means you should not collect data from the same respondent twice. For example, I have only 100, I can able to collect data only from the 100 students. I am supposed to collect data only from the 100 students only once. Today I have collected 100 data from the same respondents. Tomorrow I can give the questionnaire. I can collect the data from the same respondents. Day after tomorrow I can collect data from the same respondents. That is not acceptable. Then there should be a interdependence of observation. That means data should be collected from the only once from the respondents. Okay. Now let's take a reliability. What is reliability? First we should know the concept of reliability. What is reliability? Whenever we do the statistical test, we have to check 2 statistical tests, even though it is not related to statistical tool applications. Okay. You have 3 statistical tool. You have 3 objective, but you should apply. You should do 5 stats. You should do 5 statistical tests. One is reliability test. What is reliability test? Reliability means what? Reliability test reliability of the data can be checked with the help of one statistics called Cronbach alpha. Cronbach alpha. Actually, if for example, this statistical tool has been propounded by Cronbach in the year 1952. He has written one book called Multivariate Analysis. Even let's take Hare Anderson. Hare Anderson has written one book called Multivariate Analysis. He has written, he has emphasizing more on the Cronbach alpha. What is Cronbach alpha? I can give, I would like to give one example for the reliability of the data. Okay. I have prepared, for example, I have purchased one weighing machine. I am measuring my height. I am measuring my weight. Today it says 80 kg. Tomorrow I am measuring the same. I am measuring my weight with the same weighing machine. It shows 90 kg. And then next, after 2 days, just I am measuring the weighing machine. The weighing machine shows 150 kg. So what is the problem? The weighing machine, there is a possibility at least 1 or 2 kg maybe increased or decreased. But if the difference is very substantial, it is not good. In such circumstances, should I keep the weighing machine? No, I should discard the weighing machine. This is not good because every day it says something, it shows some different measurement. Similarly, you have purchased one weighing machine. What is the name of your weighing machine? Questionnaire. You have developed one questionnaire. You have developed one questionnaire. Okay, you have developed one questionnaire. Okay, now you are going to distribute the questionnaire with the respondent. You are supposed to distribute the questionnaire with the respondent. Okay, just you would like to measure. If you have distributed the same questionnaire with the same respondents after 6 months, will you get the same answer? No, you will not get the same answer. For example, if there is any problem with our country, say for example, if there is any foreign invasion, if there is any problem between our country with country, why? Immediately our patriotism will be very high. Yes, we will say Bharata Mata Ki Jai. At the same time, after 6 months, then we have patriotism, but then the degree might be less. If I'm in a very, very happy mood, I'm filling the questionnaire. Then say for example, the rating might be something different. When you are in the sad mood or you are not comfortable, you have been in the irritated situations, you have been giving mark or giving value for the questionnaire. How you will give a value? That's a different. So what Cronbach alpha says, okay, this is the essence of this is the objectives of Cronbach alpha. We have collected data from the respondent. If we collected the same data from the respondent after 10 years or after 1 year or after 2 years, how much response we can get? For example, if I have received 100% as it is, that is excellent, wonderful, marvelous, but this will never happen. Yes, okay, at least 90%, good. 80%, it is very good. So what should be the minimum? The minimum threshold limit is 60%. What is the minimum threshold limit? Minimum threshold limit is 60%. If I can able to get 60% of the reliable Cronbach alpha value, that is good. Okay, if it is not 60%, that is not good. So, okay, now you might ask another one questions. You might ask another one question. How to, say for example, how to calculate Cronbach alpha? How to calculate Cronbach alpha? What is the procedure? There is a nuances with regard to, there is a procedure with regard to Cronbach alpha, computation of Cronbach alpha. SPSS, I have seen some scholars, they will come. When we ask to calculate Cronbach alpha, they will include demographic profile of the respondent, they will include independent variable, they will include dependent variable. But SPSS will give some value. They will come, sir, this value is given by SPSS. This value is given by SPSS. So, shall I use the value? No, that is not correct. SPSS is like a It's an instrument. Just imagine that it's a mixie. It's a mixie. You like to prepare some chutney. At least as a researcher, you should know what are the essential ingredients, what is the proportion. Then only you can get a proper output. When you put some sand on mixie, it will give output. But can we say that this is a coconut chutney? No. Okay, so we should follow some procedure. So what is the thumb rule? You should include independent and dependent variable. You can include either independent or dependent variable. All dependent variable should have been measured only at a 5-point scale. What is the thumb rule for reliability of data? You can include all the data. All data means you can include either independent variable or you can include either dependent variable. But what is the condition? The condition is all data should have been measured at 5-point scale. If data has been measured at 5-point scale, it is good. Now, just I will perform Cronbach alpha. Okay, how Cronbach alpha can be performed? Okay, go to analyze. Okay, next, in case then go to analyze. There is an option. Called scale. Okay. So from, say for example, from the menu at the top of the screen, okay, click on analyze. Okay, then click on analyze. Okay, I have click on analyze, then click on scale. Okay, then reliability analysis. Okay, good. Okay, next one. What is the next one? Click on individual items. What is the thumb rule? What is the assumptions? You can include both independent and dependent variable, but all independent and dependent variables should have been measured at 5-point scale. Okay, let's take let's take here age, gender, work experience, nature of the family, monthly salary, reason for joining this organization. This variable have been measured either nominal or ordinal scale. So what I am supposed to do? I should not include this variable. I should include this variable. I should include this variable. Okay. I should include this variable. I should include this variable 1 by 1, or otherwise I can include this variable. I can include all the variable. Then I am including all the variable 1 by 1. Okay. Now I have included all the independent variable as well as dependent variable 1 by 1. Okay. Okay. Now let's take I have included almost all the variables. Okay. You can include independent or dependent variable. All independent and dependent variable should have been measured at 5-point scale. Okay. Now what you can do is in the model, see here in the model section, make sure alpha is selected. In the model section, this is a model section. Make sure alpha is selected. There are several other methods. Normally, we don't want this. Okay. Normally, a split of method. Sometimes split of method might be used. What is split of method? They will divide the entire data 50%. Just imagine that you have 100 data. What is the Cronbach alpha value for? First 50, rest of the 50. They will calculate. In such circumstances, you can use split off. Now, just to check, say for example, in the model section, then in the model section, make sure alpha is selected. Okay. Next. Okay. Next one. Next what you can do is okay. Click on the statistics button. Button. Okay. In the statistics button. Okay. What you can do is okay. click on statistics button, you can select these options. Just in the click on, say for example, in the descriptive sections, so just select scale if mean item deleted. Select scale if mean item deleted. Okay. Next one, what you can do is you can click continue and then click continue, then okay. Click continue, then okay. Just I will share the output. I will share the output. This is the output. See, what is the interpretation of the Cronbach alpha? How we can interpret the Cronbach alpha? See, let's take Cronbach alpha. This is the output of the Cronbach alpha value. Okay. See, check the number of cases. First, what we are supposed to do is check the number of cases is correct in the case processing summary. Check the number of cases. Number of cases means how many valid question, how many data has been collected. Let's take SPSS. We have seen 172 data has been collected. Okay. So 172 data is there. Okay. That means we have included all the data for our data processing. Okay. Good. Okay. Next, check the reliability statistics. Okay. Check the reliability statistics. Okay. What is the reliability statistics says? We have included 24 items. We have seen when we discussed questionnaire development, we have seen what is the other name of variable? The other name of variable is said to be item. Either it could be independent variable or either it could be dependent variable. The other name of variable is said to be item. Okay. So we have seen what is the number of items? 24. So what is the Cronbach alpha value? 0.934. 0.934. What does it mean? 0.934. If you have collected the same data, tomorrow or day after tomorrow or after 6 months or after 1 year, you will get 93% of the same respondents, same response from the respondent. This is the meaning of this terminology. That is reliability. There is a Cronbach alpha. So what is the minimum value? What is the minimum value? The minimum, what is the minimum threshold limit? 60. If it is 60, it's okay. Now, say for example, sometimes there may be a problem. If you have not collected this data properly from the respondent, proper sampling respondent, or you will have a problem. Your Cronbach alpha value may be 50% or 55%. In such circumstances, what you can do? It's very simple. Don't get panic. Okay, just to see the item total statistics. Okay. Say for example, in the item statistics total statistics, there are different heading. We need this value. Cronbach alpha if item deleted. For example, when I delete any one of the item means any one of the variable, automatically my Cronbach alpha value might be increasing. It might be increased. Say for example, let's say employees are treated fairly by the management. When I remove this item, my Cronbach alpha value will be improved. Okay, what is my Cronbach alpha value? 0.929. Similarly, you can go through Cronbach alpha value if item deleted one by one. Okay, you can find the least one. Just remove the least one. Automatically, your Cronbach alpha value will be increased. You can take this value and you can present this value in your thesis. But you should mention this in the thesis chapter in the statistical tool application before administering statistical tool. The researcher used Cronbach alpha value to calculate internal consistency of the data. the researcher have taken all the independent and dependent variable for Cronbach alpha value. The results are shown below. Okay. Then if you take the Cronbach alpha value, almost this is a Cronbach alpha value 24. The researcher has taken 24 items. Then all 24 items Cronbach alpha values this much. Okay. Therefore, from this we can infer that the data is fit for further analysis. This is one way of presenting. Your report. Sometimes what will happen is you might classify the data. For example, then tomorrow we are going to discuss what is factor analysis, what is multiple regression, what is correlation. Okay, so let's take you like to classify the data, you like to group the data. Now what you can do is group wise. You are supposed to present the data. You are supposed to present the data group wise. How this can be done? If you have seen the Word file, this is a way of writing interpretation for the statistical tool. Reliability is the factor that reflects truthfulness of the object of investigation. Okay. Say for example, there are several methods. There are multiple methods of measuring reliability, such as test, retest, reliability, split of reliability, Cronbach alpha, of which Cronbach alpha, just we are going to use Cronbach alpha. See here, dimensions. That means this is a construct. This construct, tangible, has 7 items. 7 items. Okay. So what is the Cronbach alpha? All 7 items put together, 0.837. Okay. So let's take responsiveness. This is a construct. This construct has 6 items. What is the Cronbach alpha value? 0.841. Okay. Now what you can do at the end, what you can do is, okay. Then researcher, you can also, if you're interested, you can also create some extra column. Number of original item, number of item deleted. What is the Cronbach alpha value? Say for example, from this table, almost all Cronbach alpha values greater than 60%. So the researcher can, the data is reliable one. So you can go by further analysis. This is the way of writing Cronbach alpha value. Sometimes, if your Cronbach alpha value is less than 60%, you can include this table. You can include this table. You can also give an explanation. This is the item deleted. Then, since the Cronbach alpha value is less than 60%, the researcher has been forced to remove the irrelevant variable. As a result, only 23 variable has been taken for further analysis. When you write, people will appreciate. Okay. So with this, I would like to wind up today's session. Tomorrow, this is our agenda. Tomorrow, we are going to discuss what is hypothesis testing, what are different types of hypothesis, how to formulate hypothesis. Again, we are going to discuss what is a factor analysis, how to write interpretation for factor analysis, multiple regression, then correlation. If time permits, we can discuss some other analysis also. Finally, we are going to discuss how to present the hypothesis testing in research paper or in research thesis. Okay. Thank you. Thank you so much. Okay. Now I am sharing. This is the output. This is the output window. This is the output window. This is the output window for the reliability test. Okay. Dear participants, okay, if you have any doubt or clarification, kindly post your queries in the chat box. Okay. I think most of the students, most of the participants says screen is not visible. Is there any other mode? Say for example, like a screen share in Google Meet. Okay, tomorrow I will discuss with the organizers. Then I will do the needful. Say for example, if I have, for example, if it is let's take Google Meet and other things, there is an option called screen share. When I use the screen share option, whatever I do, probably you can also see the same thing. Don't worry, tomorrow I will discuss this concept for 5 to 10 minutes before proceeding further. Okay. Okay. Any doubt? Okay. Sir, while calculating sample size after pilot study, which standard deviation will be considered? Okay. Say for example, this is a question related to sample size. This is a question related to sample size. Okay. Normally, sample size can be calculated with the following formula: Z stat 6 at 5%, 1.96 standard deviation at pilot study. You can, for example, when you calculate standard deviation at pilot study, you can take any one of the